Okay, today's lesson is going to focus on elements and compounds, and then also discussing what chemical changes are, and some clues that chemical changes are occurring. So let's take a little step back here and let's look at elements versus compounds. We kind of talked about this in the last video, but an element is defined as the simplest form of matter. It has its own unique properties. You learned about some different elements last year. A couple would be, let me fix that. A couple would be like sodium, chlorine, nitrogen, hydrogen. Those are all elements. They all have their unique properties. The unique properties we're going to get into later in chemistry, but those would be like how many protons, how many electrons, how many neutrons these elements have. So those are what elements are. When you move to what a compound is, that's when it contains two or more elements and they've been chemically combined, meaning they have chemically reacted. So you can have sodium, which is an element, and you can have chlorine, which is an element, but those two can go together to make sodium chloride, which is salt. You can also have hydrogen reacting with oxygen to produce water, and that is also a compound. So unlike mixtures that can be separated by physical means, and we talked about that, distillation, filtration, and centrifuge, compounds have to be broken down. Now these compounds, like sodium chloride and water, they can be broken down, but what has to happen is there has to be a chemical change or a chemical reaction. So it would be like if I take water, and you've seen a chemical reaction before, I know. Water can break down to hydrogen and oxygen. And the twos are because they're diatomic. We will discuss that later on in the course. But right now, that's what the reaction. Now, what has to happen is electricity has to be applied to water, and that will separate those bonds, and it'll break it up between hydrogen and oxygen. Sodium chloride can also decompose to sodium and chlorine. So they can be broken up, but it is just a little bit more involved than just separating them like a mixture can be. So that's just the difference between what an element is and a compound is. Looking at a chemical change, we did discuss physical changes, but chemical changes are changes that produce matter that is different from its original form. So you no longer have something in its original form. Like if I cut paper, it's still paper. That's just a physical change. But if I look at a chemical change, like my examples here, I have sugar. The chemical formula for sugar is C12H22O6. If I take sugar and I heat it up, so I'm going to put an arrow, and I'm going to show heat, meaning heat is going to be applied to it. What happens is it breaks down, and it breaks down to carbon and just water. So there's the chemical reaction for that, and that's a chemical change when that happens. I can't get that sugar back. Once I've got the carbon and the water, it's no longer sugar. Another way, and I've already discussed this one, but water. When I apply electricity to it, it separates that bond, and it breaks it up into hydrogen and to oxygen. Now if you think about this, water is no longer water anymore. Hydrogen is a gas, and oxygen is a gas by itself. Water is a liquid over here. So once that electricity is applied and you've separated those, you can't go back. You can, it's going to take another chemical change, but right now it's broken the bonds and it's separated it to hydrogen and oxygen. So one thing to remember is elements versus compounds. Always remember that the properties of the compounds are much different than the elements that make them up. Kind of like what I discussed. If you think about water, it's a clear liquid. But if I apply electricity and break this up, I'm breaking it up to hydrogen and oxygen. Those two are both gases, and you can't see them. So there is a big difference between what happens in the beginning of a reaction and the end. So just keep that in mind, the difference between the elements and the elements that make up those compounds. They do change their properties. Just to kind of recap here, the classification of matter, and this is kind of covering what we've done this chapter so far. If you've got matter, if it can be separated by physical means, if you follow this arrow right here, it's a mixture. So then you have to decide, is that mixture heterogeneous or is it homogeneous? So then that's kind of the difference there. So homogeneous, remember, were solutions where you can't tell that something's been mixed together, and heterogeneous was you could tell. It would be like Rocky Road. And that's just kind of a review. If your matter cannot be separated by physical means, we're over here on the left now, it means it's a substance, meaning a pure substance, which can be an element or a compound. So an element is an atom of a single type. Compound is two or more different ones. So this would be like sodium. This would be like sodium chloride. So that's just a review of the classification of matter. Now, moving on to chemical reactions. Chemical reactions are chemical changes. They involve words such as burning, rotting, rusting, decomposing, fermenting, exploding, and corroding. And if you just try to remember, it's changing or altering the identity of that substance. So when you take iron and you set it out and expose it to air, it's going to do what? It's going to rust. So when it rusts, it no longer is iron. It's now become iron oxide. So that is a chemical change that is occurring. Another example of the difference between these two, a physical change, if I take a mixture of iron and sulfur, so I'm showing you the picture here, there's sulfur in this one, iron in this one, and I put them together and just kind of mix them up in a bowl down here. Iron is magnetic, sulfur is not, so I can take a magnet and I can get that iron back out, so I can separate it. They have not chemically reacted together. This would be an example of this. It's an old game that I played when I was little, and I think they still have them at Cracker Barrel, where you have the face and you can move around the little shavings and put the beard on the little guy. So that's iron in there, or some kind of metal that is magnetic. But if I make one small change to this, and the small change is the fact that I'm heating them up. Once I heat those two things up, they do react together and they form something called iron sulfide. So I'm taking iron by itself, reacting it with sulfur. It needs heat for that to happen, and it becomes iron sulfide. Then it is a chemical change. Now it's been altered and it's now a compound. So that's the difference. Chemical reactions involve reactants and products. You kind of learned about this last year in physical science, but if I have H2 plus O2 yields water, these over here on the left are my reactants with the red underline, and this one over here, the blue on the right, those are my products. So that's the difference between that. I also have another example. Say you have nitrogen supposed to be an N, plus hydrogen can react to form ammonia. So these are my reactants, so I'm going to put an R to kind of help you out. And then the blue, those are my products. So what you have to also remember is that in a chemical reaction, the mass of the products is always equal to the mass of the reactants. So that is the law of conservation of mass, and you learned about that in physical science, meaning the way I describe it is whatever's on the left has to be on the right. So you would have to balance it. So if I'm looking at this chemical reaction over here, I would have to say it takes 2 hydrogens, 1 oxygen to produce 2 waters. And on the right side, it would take 1 nitrogen with 3 hydrogens to produce 2 ammonia. And that would meet the requirements for the law of conservation of mass. So we will do chemical reactions again in balancing, but that is later on in the year. Last slide here, talking about the clues that a chemical reaction has occurred, and it looks like it cut off some of my stuff. It's clues that a chemical change has occurred. So the 4 clues that you're looking for is a transfer of energy. If you feel a test tube and it gets hot or cold, then you know that a chemical change has happened. If something changes color, like my picture here, it starts out as green, it ends as red. So in that case, it's going to be a chemical change. Not always is a color change, a chemical change, but for the most part it can be. If you have any kind of fizzing or foaming or gas being produced, so if you mix vinegar and baking soda, for whoever's done that, lots of bubbles form. So when bubbles form, that's telling you that a chemical reaction has occurred. And my last one, my picture's kind of cutting it off, but it is the formation of a precipitate. That's a solid that forms in the liquid. So if you take a look at my picture, it is a yellow liquid in the beginning, but it's a clear yellow liquid. As soon as I add that liquid to the clear liquid in the bottom beaker, it now becomes, right there, that yellow solid precipitate. And you will see something form. It's not always going to be yellow, it can be different colors, but it is a solid that will form when you mix two liquids together. So that is a discussion of Chapter 2, looking at matter and the changes in matter. So that is the end of this lesson, and go ahead and do your problems for this, and that's your assignment.